For the last section of the review, we're going to move to coordinate proof with our quadrilaterals and proving what shape we do have. So in order to do that, as we talked about in class, we would probably find the side lengths and then the slopes for that sides. So I'm going to start off by finding what is the slope, rise over run. So we go up 2 over 1, 2, 3, 4, 5. So it's a rise of 2, a run of 5, and it is a positive slope since it's slanting up towards the top right. We can do that for each one. We're going to say for AB, you would go up 1, 2, 3, 4, 5, back 1, 2. This is a negative 5 halves because we're slanting backwards. This would be a positive 2/5 up 2 over 5 and up 5 back 2 for CD. So that would be a negative 5 halves. From that right there, we know that we have a parallelogram because both pairs of opposite sides are parallel. We also know that the sides are perpendicular to each other. The adjacent sides are perpendicular because the slopes are opposite reciprocals of each other, which means that we have perpendicular lines. So therefore, if we have a parallelogram with 4 right angles, then we know we have a square, or we have a rectangle. So right away we know we have a parallelogram and a rectangle just by finding the slopes of the sides. From this, we can then find, so our next question is it a square? So it's a rectangle, is it more specifically a square? Because it sure looks like it. So we're going to start off with, let's use the Pythagorean theorem. You can use distance formula if you want, but since what I showed you in class is the Pythagorean theorem, we're going to use Pythagorean theorem. And here is our right triangle. One leg is 2, one leg is 5. The hypotenuse would be AD, the side we're trying to find. So A squared plus B squared equals C squared, the Pythagorean theorem. We have 2 squared plus 5 squared equals C squared. 4 plus 25, I'm getting ahead of myself, equals C squared, and that would equal 29. And then we need to take the square root of both sides to get rid of that square. So C is going to equal the square root of 29. We don't need to take it any further than that. It's actually simplified the way it is, but we don't need to take it any further than that. So this is the square root of 29. This one over here is 2 and 5, which is the same as the one we just did. So that would be the square root of 29. And what we'll find is 2, 5 for all the rest. So all of them are the square root of 29, which means all sides are equal. So then what we do is we would say, the most specific thing that this is a square. And why do we know it's a square? We would say both pairs of opposite sides are parallel. All sides are equal. And all adjacent sides are perpendicular. Which means that we have 4 right angles. Because we have all sides are equal, which means that that's a defining characteristic of a rhombus, and all adjacent sides are perpendicular, 4 right angles, which is a defining characteristic of a rectangle. We have a rhombus and a rectangle, which is a defining characteristic of a square. So therefore, a square is the most specific for this type. Okay? Let's go to the next one. Okay? Again, we're going to find the slopes of all the sides. For zy, we would go up 1, back 3. So 1 over 3, and it's going to be a negative because we're slanting backward. For xy, we would go up 3, back 1. So 3 over 1, and again, that would be a negative. Wx, we're going to go up 2, back 6. So 2 over 6, which is a negative, and that can simplify to negative 1/3. And Wz is the last one. Wz goes up 2 over 2, and that is a positive, because it's the only one slanting towards the upper right. So it's positive 2 over 2, which equals 1 over 1. It simplifies to 1 over 1. Okay, so do we have any pairs of parallel sides? And zy, we see negative 1/3, negative 1/3. Those two are equal, so therefore since the slopes are equal, those lines are parallel. So this line is parallel to that line. If we look at the other ones, xy and wz, as you might have guessed just by looking at it, but again, that's not a reason. They don't look like that they're parallel, and their slopes are not the same, so therefore they're not parallel. So therefore we have one pair of parallel sides, which is a defining characteristic of a trapezoid. Okay? We could go a little bit more in detail and see, is this a right trapezoid, isosceles trapezoid? For that, you would have to find those side lengths. This one then would be 2 legs of 2 and 2, which would give us 2 squared plus 2 squared equals c squared. 2 squared is 4. 2 squared, another 2 squared is 4. That equals c squared. So 8 equals c squared. C equals the square root of 8, which would simplify to 2 square root 2. The one over here, it's 1 and 3, so it's going to be 1 squared plus 3 squared, which would give us 10. And then we have to take the square root, so this would be the square root of 10. The square root of 10, of course, does not equal the square root of 8, so therefore x, y, and wz are not congruent. If they're not congruent, that means that it's not an isosceles trapezoid. We also know that xy is not perpendicular to zy or wx because its slope is not opposite and reciprocal. It is the reciprocal, but it's not opposite. So it has to be both in order to be perpendicular. And wz as well is not opposite reciprocal. So this is a trapezoid because it has one pair of parallel sides. And that is it for this part.